Okay, so I've had a couple people that who've been, either following along for a while, and one or two new people that wanted to know, keep up with my project here on the gravity-driven generator. So I promise I'd run a video of where I'm at, and forgive me if the light's a little off. I'm doing this at night, but so. The last video I ran was about dealing with the deflection on the transfer shaft. And there's the wheel, well, I call the winding wheel. Okay. And most of you who've been following know what this is all about. But anyway, just for those of you who are kind of new, chain comes down. And before, just ran to the transfer shaft without having this post here, and there's one next to it over here, right? It's just a shaft that ran along here and went over to this sprocket, and that sprocket goes down, connects to the gearbox via chain, right? And then there's your gearbox with some really high ratio gears. I mean, I should say sprockets to be specific. But anyway, so I was having a real big problem with shaft deflection, right? And I tried some different things. I actually tried to wrap the shaft in some DOM pipe, and the math said it would work, but it didn't. So that was something I tried. It doesn't work. So do yourself a favor, don't try that because it won't work. But anyway, I bought two what we call C-channel. I don't know if you can really see this with the way this video is coming out, but it's called C-channel. Some people call it U, but it's a C, and it's just C-shaped, right? And there's two pieces. There's one here, and there's one here, and they're about maybe, I don't remember the exact height, but these are about 4 feet tall, I guess, somewhere around there. And I just took two bearings, which this silver shiny piece is a bearing shell. These are cheapy low buck bearings. Inside this shell, they clamp inside, and you just put two halves together. Even though you can't tell in this video, there's actually an outside and an inside, and in between you have a bearing. Okay, and there's a bolt here and a bolt on the bottom, right? So you're just sandwiching the bearing between two sheet metal casings. Okay, and then same thing on the other side, on the other post. So obviously the bearing diameter fits around this piece of steel shafting, right? And I have some little split collar, lock collars here, just to keep this whole thing from moving around, right? So it won't slide under load. And inside, where you see this sprocket here, there's a sprocket right here. The chain runs around it, okay, and goes up to the winding wheel, right? But inside here, there's some more split lock collars in place that you probably can't see in this video, but they're in there, and they keep the sprocket from sliding left and right and walking around. There's actually a split lock collar right there that I'm pointing at, and there's another one inside there that we can't see in this video, and that keeps this sprocket from walking under load. Okay, these two posts, which are just basically low buck steel, right? Or even, they're not cast iron, but they're low buck steel. I got them at the local metal supplier here up in my part of Texas that I live in. Okay, further down, you can see that I just put in some threaded rod, okay, and there's bolt on the outside and each side, and on the inside in here is some more bolt and lock washer on the inside. So that keeps this space between these two support posts equal, right? And there's one further down. Okay, and you'll notice it goes all the way to the floor. Okay, so those posts were perfectly measured height-wise. okay, to match the height of this post off the cement floor in the garage here. Now, why did I do all that? And how did that solve my shaft deflection problem? Well, let me introduce some weights. So there's Olympic weights that are just at the bottom of those two posts. I just mounted one of these guys. You know, I don't know if you can see it in this video, but it's just your typical power rack tube that, you know, mounts to the side of a power rack that holds Olympic plates, right? They just slide on there like that. So I just, I don't know if you can see them, but they're bolt. There's the top bolt, and there's one at the bottom. You can just see the head of it right there, right? So the Olympic plates just sit on this. Sorry about the video here. It's kind of hard to do all with one hand, but there's a little tube right here. I know it's kind of hard to see in the video maybe, but there it is. A little better view of it, right? So on this one side we're looking at it right now, because I ran some tests a few weeks back. Let's see, 45s, 90, and I don't know, 35, 125, I guess, plus another, what, 10. So I don't know, 145 pounds a side, something like that, I don't know. Somewhere around, I got about 290 pounds, I think, sitting on there, because I had the same thing on the other side, on the other post, right? Okay, so the reason why this works, and it works really good, it keeps the deflection down to a minimum. For those of you who are not sure what I'm talking about, what type of deflection am I talking about? Well, when the winding wheel pulls on this chain, right, it creates a load on the chain. That load is upward. This shaft wants to flex. I'm just going to get my hand over here, right? Wants to flex like that, right? Wants to bow up. Okay? And it bows really bad if you don't have it under control. And why is that a problem? Well, you get too much chain slack. The chain will slack a lot when you have a lot of bowing going on, right? So you got to control that. There are different ways to do it. You know, this is not the only way to do it, right? There's other ways, but this is a low dollar, economical way to control deflection. There are other more advanced and more expensive ways to deal with that, right? I mean, there's a lot of different ways to handle this. Anyway, this is the way I dealt with it. It's working really good for me. So for those of you who just kind of wanted to know where I was at on the project and how I dealt with keeping that shaft, transfer shaft, from deflecting, that's how I did it. A lot of times in industrial applications, that shaft will be a really large diameter. This shaft is 1 inch in diameter. But in industrial applications, you know, that shaft might be 3, 4, 5, 6, even a foot in diameter, right? And the bearings that hold it in industrial applications, the distance between the two ends would be very short because they really want to control the deflection, keep it under control. Well, I don't have that luxury because, first of all, that's very expensive material to go with large diameter shafts, right? So, an economical way is this is one of the things I came up with and works really good. I've tested it, I've measured the deflection. The deflection is very minimal, even with 400 or 500 pounds on there. Deflection pretty low. I actually ran a test to see if the gearbox would turn and everything about 2-3 weeks ago, and I hung on there, those weights down there. Again, that's about 250 pounds, a little bit under what I needed to turn the gearbox. I need about 290 to turn the gearbox based on my math. But this bicycle wheel, which is only about 27 inches in diameter, and it just couldn't handle the load. It started really flexing and it started pitching out this way really bad under load because the sprocket's on that side, that big sprocket. And it just started flexing really hard left under load, right? It went like this, started bending that way. And so I already knew based on the math that this bicycle wheel was probably going to reach its limit, and it sure did. It didn't break, but it's you know, it's not usable. So we're going to take it down. In the town I live in Texas, we have things like wagon wheels. So a steel wagon wheel, which is fairly inexpensive, used. Lots of those laying around out here in Texas. So I'm going to grab one of those up real soon here and get back to reworking the top side of this. And then I'll run them another video. That's just the way it is, guys. You got to iterate through projects one step at a time and find out what works and what doesn't work. And you know, if I could afford an engineering company and they'd throw a bunch of their effort at making this work, that'd be great. But I'm not going to do that, and I can't do it for various reasons. So I've had the gearbox turning already a little bit in the past, so I know the gearbox is pretty decent. There's a little more work to do on the gearbox. I'm noticing a few little hang-ups, especially where half links are concerned. But I think it's manageable. And one other thing I do want to say before I stop this lengthy video is that the weight here that's keeping the shaft from deflecting is also a really good ballast or a balance to keep the entire weight rack from rocking forward and rocking back. Okay, you got 200, when you got several hundred pounds hanging, you know, off this back pulley here. That's a boat winch that does the winding part, and I extended the handle nice and long. But when you got several hundred pounds hanging, the weight rack in this case wants to tip back towards me this way, right? It's not perfectly centered, and even if it was perfectly centered, you're still going to have a lot of movement when you're dealing with a lot of weight. It's just, unless this thing's bolted down, and most industrial applications, this whole entire apparatus would be bolted down and you wouldn't have those issues, right? But this is a freestanding device, right? It's just loosely standing here on a garage floor. And frankly, I really don't want to bolt it down, you know? It's something that if you take the weights off, you want to be able to move it around and put it where you want it. So I noticed that it didn't not only did it help with the shaft deflection, it also helped in keeping that load that's falling properly balanced with this other load out front, and the whole weight rack is just a lot happier and doesn't move around, and so that's good. Okay, so anyway, the video is really long, and there you go, guys. I hope you enjoyed the video, and I'll run some more as soon as I got some progress and something worth videotaping, okay? All right, God bless you guys. Take care.